Determine the equation of this quadratic function. F at x equals ax squared plus 5x minus 8. So to determine the equation, we need to find a. We also know that for a particular value of x, -1, for a particular value of x, -1, we get a y value of -10. So we're going to use the point -1, 10 in f at x to find a. So as you can see, I've substituted the value of -1 into all of our x terms, and -10 is on the left side. That's our y value. So I'm just going to evaluate. At this point, I'm going to simplify, so I end up with -10 plus 13 on the left side equals 1a. So 3 equals 1a. And then the final quadratic function is f at x equals 3x squared plus 5x minus 8. Good luck studying. Next question. Given f at x equals 2x squared plus 4x minus 30, we need to, A, determine the vertex. I'm going to begin there. To determine the vertex, we will complete the square. To complete the square, I'm first going to take out the a from the 2x squared and the 4x term, and then I'm going to complete the square by asking myself, what is half of 2, this 2, squared? So that'd be half of 2 is 1, and 1 squared is 1. So I'm going to rewrite the next line. I've rewritten the next line to complete the square. So I added 1 and subtracted 1. What I'm going to do now is I'm going to look at the first three terms here, and that's going to give me a perfect square. So I'll write that out now. That's x plus 1 squared, and the minus 1 is still there. So it's impacted by the 2 out front, so I need to make sure I don't get rid of it. I'm going to follow up here. So then in this line, I'm going to do the distributive property to get 2 times x plus 1 squared, minus 2 minus 30, and finally 2 times x plus 1 squared minus 32 is our final answer. Therefore, the vertex is -1 and -32. Because my a value is positive, it's 2, that means that my parabola opens up. For the axis of symmetry in the zeros, I think I'm going to try factoring it. So going back to my original equation, 2x squared plus 4x minus 30, I'm going to factor out a 2, so x squared plus 2x minus 15. Then I'm going to ask myself, what two numbers add to 2 but multiply to -15? So I get 2x plus 5, x minus 3. Therefore, in factored form, we're able to say the zeros. Therefore, the zeros are x equals -5 and x equals 3. Because this is a parabola, the domain would simply be all values of x. So any real number is my domain. The range, because it opens up, and the vertex, so I'm going to just do a little sketch here. The vertex is at -1 and -32, and it opens up. That means that my range must be greater than or equal to -32. Okay, so I already did a little mini sketch, but let's do it again. I'm going to label my axis x and y. I think I'll make this 15, -15 and -30, and then up here 15 and 30. So my vertex would be at -1, so let's call this -5 and call this 5. So -1 and -32, so it'd be down here somewhere. My zeros are x equals 3, so that would be, I should probably change colors, right? X equals 3 here. Oops, sorry. 3, and x equals -5, so here. So I have the 2 zeros and the vertex, so all I'm going to do now is join those points to make my sketch. And then now the question's done. Thank you. So the break-even point is when the profit is 0. So we need to find out when this is 0. I could potentially factor it, or I could use the quadratic formula, but it says whether it's possible and state how many ways. So I'm going to start just with the discriminant, actually. So d equals b squared minus 4ac. Substituting those values in, I get 9 squared minus 4 times minus 5 times minus 3 equals 81 minus 20 times 3, so 60 equals 21. Our discriminant is greater than 0, therefore there are 2 ways to break even. Some of you went on to use the quadratic formula to find out exactly what values of x would be break even, but this question didn't ask for that, so I'm just going to go with this. These are radicals, and we're going to use the distributive property to figure out, to multiply out these. So I'm just going to write it very explicitly. 4 root 8 times 3 root 5, that's the first arrow, plus 4 root 8 times root 2 is the second arrow. Now I'm going to figure out, I'm going to sort things so that numbers are together and radicals are together. So 4 times 3 times root 8 times root 5 plus 4 root 8 root 2. Now I'm going to combine the 4 and the 3 to get 12 and to get root 40 for 8 times 5. And over here I have 4 times root 16. If I can simplify those further, I need to do that. The perfect square that goes into 40 would be 4, so 4 times 10. And the root of 16, we already know, is 4. So here I get 12 root 4 root 10, pulling those apart, plus 16. And then 12, the root 4 is just 2, root 10 plus 16. So my final answer is 24 root 10 plus 16. To determine if these two functions intersect, we're going to set them equal to each other to find out when f at x crosses or intersects with g at x. So I've simply set them together already. I'm going to use the distributive property to expand these brackets on this side. At this point, I've expanded the left side by using the arrows, and I've simplified the left side. So now I'm going to collect everything on the left side. So what that means is I need to subtract the 7x from here and add the 6, but I need to do that to both sides. So my resulting quadratic would be 2x squared minus 6x minus 30 equals 0. At this point, I'm going to try factoring it to see if I can find the x values for the intersection points. I'm going to common factor out a 2. Okay, so I thought about it, and it looks like I cannot factor this. So I feel like I need to use the quadratic formula in order to find the x values. When I find those x values, I can find the corresponding y values, and those will be the points of intersection. So I use the quadratic formula in order to find the two values of x where the quadratic and the line meet. So I ended up with 5.65 and negative 2.65. The last step is just to put those back into one of the original equations to find y. In order to find the y values, I'm going to put them into the second function, g at x equals 7x minus 6, because I think that will be easier to calculate. So I put those two values into g at x, and then I ended up with the 2 points. So the first one is 5.65 with approximately 33.55, and the second point is negative 0.265, and when I plugged that in, I got negative 24.55. Last thing I'm going to do is double check my work in Desmos, and I'll post the graph here. Okay, so I've posted the graph, and you can see that the 2 points of intersection are here and here. So those are approximately the same values that I have down here that I worked on algebraically. Good luck on your studying.